All right, so here we have Ryan's rational function, and what we want to do is to factor this function down to its most simplest form so that we can graph it. So we start by factoring out a 3, and that'll leave us with x squared plus 5x plus 6 in the numerator, and x plus 3 over x plus 2, or excuse me, x plus 3 and x minus 2 in the denominator. Then we can factor the numerator even more by the simple way, 2x plus 3 and x plus 2. And our denominator is going to stay the same at x plus 3 and x minus 2. Now both those x plus 3's cancel out because they're in the numerator and the denominator, which leaves us with our most simple form of 3x plus 2 over x minus 2. So we know that because that x plus 3 cancels out, we have a whole at x equals negative 3. Now in order to plug in to find our corresponding y value, we have to plug in negative 3 into the simple function to find the corresponding y value. So when plugging that all in, that will simply give us 0.6. So that's our corresponding y value for that. We look at our vertical asymptotes, x minus 2. The denominator can't be equal to 0, therefore x cannot equal 2. And for our horizontal asymptotes, now we take our original function and we divide everything by the highest power of x. So we have 3x squared over x squared, 15x over x squared, 18 over x squared, and all of that is over x squared over x squared, as well as x over x squared and minus 6 over x squared. Now when we simplify that down, that is simply going to give us 3 plus 15 over x plus 18 over x squared over 1 plus 1 over x minus 6 over x squared. Now, we set x equal to infinity, which will cause anything over x to be equal to 0. So as we change all of that equal to 0 in our equation here, which will simply leave us with 3 over 1, or even simpler, 3. So we now know our horizontal asymptote is at y equals 3. Now in order to find our x and y intercepts, we just have to set the other one equal to 0. So for our y-intercept, we set x equal to 0. So we have 3 times 0 squared plus 15 times 0 plus 18, and all of that is going to be over 0 squared plus 0 minus 6, which will give us 18 over negative 6, which can be reduced down to negative 3. So now we know our y-intercept at negative 3. Then for our x-intercept, we set y equal to 0, and we use our simplified one here just to make things easy. So that's 3x plus 2 and x minus 2. We multiply everything in the denominator by both sides to get rid of the fraction. So that simply leaves us with 0 still on the other side. Now that we have our equation here, we divide both sides by 3, which again gets rid of the 3. That'll leave us with 0 equals x plus 2. And then we move the 2 over to the other side, which will leave us with x equals negative 2. Now we skip to our graph here, and we're plotting in our horizontal and vertical asymptotes here at x equals 2 and y equals 3. We plug in both our y and x intercepts. We also can't forget about our whole at negative 3 and 0.6. So now skipping ahead to the table of values, this will help us determine the end behaviors in our graph. So when we set x equal to just before and just after the vertical asymptotes, which I chose negative 2.01 and negative 1.99, you'll see that will give us both very large and very small numbers, which helps determine our end behaviors. Now when we also set x to be very large and very small, as you can see I chose 1,000 and negative 1,000, that will give us 3.01 and 2.98. Now as we skip to the graph here, as I said, when x is very small, y is just below the asymptote, and same thing vice versa, much like the same thing for the horizontal and vertical asymptotes. Now, we have enough points here to graph this function. Keep in mind watching that hole just to lift your pencil and to keep graphing down. So there's one completed graph. Now we also need to find points to complete this graph over here, which I chose both to be 5 and 6. So those our corresponding y values are 7 and 6. So when we plot our points here, that gives us 7 and 6. And now we can graph this function here, which is now completed. And that is your completed graphed rational function.